Hey guys, how's it going? Welcome to day 52. Good work with the initial condition plus C. We're going to see that again today a little bit as well. Initial condition plus the integral. Today we're looking at integrals of velocity. What does that mean? What is that? How do we solve problems looking at that? Well, we know that the derivative of velocity gives us acceleration. And we know that the derivative of our position function gives us velocity. So an integral of velocity is going to relate back to our position function. Also, if you do a unit analysis and think about it, if velocity is measured in meters per second and time is in seconds, the integral of v of t dt would give us a unit of meters, right? Which is relating more to distance and things like that. What we have to be very careful with integrals of velocity is the difference between displacement and distance travel. So let's take a look at just a definition here that I want you to circle in your notes. Okay, so when we integrate a velocity function from A to B, that gives us the total displacement of the object from t equals A to t equals B. Now, I want to talk a little bit about the difference between displacement and distance traveled. Displacement, all it looks at is your starting position, your final position, and the difference between those two. Distance traveled would be a little bit different than that, or could be different than that. So let's take a look at this. I want to give you the other definition here, just so you have them both in your notes right off the bat. So this is our first start equation. Okay, so I want to start this by talking about the difference between displacement and total distance traveled. All of you guys have taken physics in some form, so we should already be familiar with this, but it's good to check it out again and think about it again in the context of calculus. So let's talk about the difference between displacement and total distance traveled. Okay, so let's take a look at just a little motion map here. So I have a number line. Okay, so if I have a number line, if I have an object that starts at a position of -1 and it moves to the right 3 and then back 2. This is its final, right? So this is like t equals a, and this is at t equals b. Okay. I'm going to talk about distance traveled versus displacement. So the displacement here would be, where did I start, where did I finish, and what's the difference? Remember, moving to the right counts positive, moving to the left counts negative. So I started at -1, I finished at 0. My displacement here would be 1. My total distance traveled, though, would be different. My total distance traveled, I traveled 3 to the right and 2 to the left. My total distance traveled would be a distance of 5. So if I did an integral from a to b of v of t dt, right, I'd get an answer of 1. If I did the integral from a to b of the absolute value of v of t dt, I'd get an answer of 5. Okay, let's take a look at another scenario. Okay, so let's say I start at 6. I go back 1, 2, 3, 4, and then I go forward 1 and I finish here. My total displacement is, where did I start, where did I finish, what's the difference? Well, I finished 1, 2, 3 to the left of where I started. So my displacement would be -3. My total distance traveled would be, again, 1, 2, 3, 4, 5. My total distance traveled would be 5. Our displacement can be a negative number. Our total distance traveled cannot be a negative number, right? We can't travel negative distance, but we can have negative displacement in relationship to where we were and where we're going. Okay, so we want to understand that idea, okay? Imagine that you think about, let's say you're at home and you travel to school because you forgot your calculator, and then you drive back home, okay? Let's say you live 5 miles from the school. Well, that whole trip from home to school, back home again, what would your displacement be? Well, your displacement would be 0 because you started and finished in the exact same spot. What would your total distance traveled be? Well, you went 5 miles to school, 5 miles home from school. That's a total distance of 10 miles. So this idea of total distance and total displacement can be different numbers. They can also be the same, right? Sometimes they are the same, as long as we're only going in one direction. Right? If I start at a position of 2 and I travel to a position of 5, well, here my total displacement would be 1, 2, 3. Sorry, my displacement would be 3. My total distance would also equal 3. So if we only travel in one direction and we're going to the right, my displacement and my total distance traveled can be the same, right? It's like I never had negative velocity. I never went to the left. Okay, so displacement and distance traveled can be the same. But more often, especially on AP Calc, they're different quantities. Okay, so let's talk about how we use this in the context of a problem. It's used in a couple of different ways, and it's important to know what we use and when. So let me write you a sample problem here. So let's say I'm not going to give you an actual equation here. We'll see those in the homework tomorrow, but the setup here is more important, right? Doing the integrals, we know how to do those by hand. We also can do them on our calculator. Sometimes these come up as calculator problems. So let's just say we have an object travels at a velocity of v of t, so some function v of t, on an interval between 0 and 5 for t. Oftentimes what they'll do here is they'll give you a starting position for an object. Although it's not always a starting position, they'll give you a position at a certain time. So they'll say at t equals 0. They'll say at t equals 0, x equals 4. Remember, x is a common letter that they use for position, right? X of t, right? So what they're saying here is x of 0 equals 4. So that means at time 0, I'm at a position 4. Now, I'm going to show you the two different types of questions that they might ask here and how we answer them and how they're different from each other. Here's one question they might say. They might say, find the position of the object at t equals 5. So I want to know, where is that object located at time t equals 5? Well, what would I be more concerned with, total distance traveled or total displacement? Well, since I know I'm starting at a spot of 4, if I knew my displacement, right, let's say my displacement was 2, that means from 0 to 5, I went a distance 2 to the right. I finished a distance 2 to the right of where I started at. Well, would my position be 2, or would it be different than that? Well, if I finished 2 to the right of where I started, and I started at a position of 4, that would mean I'd finish at a position of 6. Okay? So what I have to do here, right, if you're ever asked to find a position at a specific time, okay, what we have to think of is just like the video from our last video, which is initial condition plus. So here's what we know. From this, I know that x of 0 equals 4, right? And what I'm looking for is the position at time 5. So I'm looking for x of 5. Well, what I know about position is it's the antiderivative of velocity. So what I have is an initial condition, and I'm going to add that to my integral from the time I have 0 to the time I want 5 of the integral of the function v of t. And so that's going to allow me to set this thing up. Again, this is a question of displacement in reference to my initial condition. So just like in our day 51 notes, I'm going to take my initial condition plus the integral from the number I have to the number I want of v of t dt. Notice that I don't have absolute value signs because that will give me my total distance traveled. Total distance traveled is not going to help us here because I could be going to the right and then left and then right and then left, and I don't know where I'm ending up. Okay? So again, if you take a look back here, right, we see this integral a to b of absolute value of v of t, the second one down there. Absolute value gives me total distance traveled. That's not what I want. What I want is displacement to figure out where I am. Okay, so let's go back. Setting up this equation will give me my answer of my position at time 5. And again, it's just like initial condition plus. Okay, so what this means is I'm starting at a position of 4, right? That's the 4. I add in my total, my displacement from 0 to 5, and that will give me my final position that I'm looking at x equals 5. Okay, another question that they could have asked here is this. What is the total distance traveled by the object in the first 5 seconds? Well, this is pretty obviously a total distance traveled one. I do not care about where I started or where I finished. I just care about how much distance did I travel, right? From home to school back to home again, I'm looking for that distance, total distance of 10. Okay, so if I wanted to solve this one over the first 5 seconds, my answer would be the integral from 0 to 5 of the absolute value of v of t dt. That absolute value is going to count both moving to the right and moving to the left, not as a positive area and a negative area, but counting it all as positive area to figure out my total distance travel. Okay, so we want to keep these two things, know the difference between them. Let me just show you one more quick example through a graph here. So let's say we have a graph that looks something like this. Let's say that they tell you that, let's say 0, 1, 2, 3, 4, 5, 6. Let's say that this area was an area of 10, and this area is an area of 3. Okay. So again, I just have a velocity graph here. And again, they could ask several different questions. Here's what they're going to tell you. At t equals 0, my position x is, let's say, negative 6. So we start out with a negative position. I'm at the position negative 6. And I want to know a couple of things. What is my position at time t equals 4? What is x of 4? So if I wanted to find my position, where am I located at time t equals 4, right? This is a displacement question. So I'm going to take my initial condition, right? Again, thinking about this as a point would say x of 0 equals -6. Right? To find x of 4, I would do my initial position plus the integral from the time I have to the time I want of t dt. Okay. I can figure out this integral I can solve by the graph. They told me that the area from 0 to 4 is 10. So my answer would be -6 plus 10, which equals 4. What about my position at x at time 6? What is my position at time 6? Well, again, to do that, I need to use my initial condition plus my integral. So I'm going to take my initial position, my initial condition of 6, plus the integral from the time I have, 0, to the time I want, which is 6, of v of t dt. Again, when I do this integral, I'm going to count this positive 10, but this 3 is going to count as negative. 10 plus -3 is 7. So I've got -6 plus 7, which equals 1. So x of 6 would be 1. But what is my total distance traveled? On the interval 0 to 6. Well, that would be the integral of the absolute value of v of t. And what that, in a sense, is doing, right, is it doesn't allow that graph to go negative, and it bounces it up the same way it would positive. So basically what it does is it adjusts this graph to look like this. This region doesn't change, but this region would do this now. And I'd have a 3 up here. And that 3 now is going to count as positive. So my total distance traveled on 0, 6 would now be 10 plus 3, which would be 13. So my total distance traveled, right, is going to be, in this case, a bigger number than my displacement over that same interval. My displacement was 7. My total distance traveled was 13. Okay, something you have to be aware about. Sometimes they give you a position, but it's not at time 0. Okay, so let me just show you that real quick, and then we'll be done. So this is an area of 5. This is an area of 12. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. So this is a graph of v of t. Now, what they might say at t equals 10, x equals 4. So at t equals 10, x equals 4. What we need to be careful about here is that is an initial condition, but it's not my initial position. It's actually my final position here. So again, what I know here is x of 10 equals 4. That's the point I have. So they might say, well, what is x of 0? What is my position at the beginning? Well, again, I can solve this in the same way. Right? I can still calculate this by using this condition here, right? And what I can do is say, okay, I'm going to do 4 plus the integral from what I have. What we have to be careful with here is the bigger numbers on bottom to the one I want of v of t dt. Again, if we don't like solving that integral with the bigger number on bottom, we can simply switch that to be 4 minus integral 0 to 10. of v of t dt. Okay? You're going to go from 0 to 10 of v of t dt. Well, this would count as a -5, and this would count as a +12. 12 minus 5 is 7. So my answer would be 4 minus 7, which equals -3. And that would be my position at time 0. So just be aware, just like when I give you initial condition plus, sometimes I give you a point that has a bigger x value. Sometimes in these velocity ones, I give you a time with a bigger t value. And just know that if we're just careful about it, we can solve it just as easily with a few minor adjustments. Okay, that's it for today, guys. I will see you tomorrow. 2 trains, bye.